I want you to be patient for at least 2 hours, okay, to understand the sessions, guys. And this is completely live coding as well, completely live coding as well. And I'm going to explain each and every concepts of deep learning. Okay. And let me talk about, so regarding my introductions, I hope most of them knows. I mean, a lot of my enrolled student also joined today's workshops, and the one who never enrolled this before. So the first point, let's give my introductions as well. So here, my name is K. Prakash Senapati, guys, and I have almost like 16 plus year experience of IT experience, all right, into various MNCs and the internationals, and we have in Indian organizations as well. And I want you to, for more details, I directly give you can follow me LinkedIn. This is my LinkedIn profile, and all the projects and some of the competitions and all those things I've been mentions here. Yes, guys. So you can follow that. And the second thing, I do understand while the session, you have a lot of questions. I will address your question at the end. Okay. Apology for that, because if I started answer your questions, it's 1 hour, it's gone like that. Okay. So please, I hope you bear with me and we can continue the sessions, and I'll address your questions at the end. Okay. And also you can follow me in my LinkedIn, and I've been a Microsoft certified data scientist as well. And I've been trained many of the corporate as well as I'm in freshers expertise and some of the good audiences as well. All right. So this is all about a little bit about my introductions. Okay. Now the main important prerequisite, what exactly required before we start this program? A minimum machine learning knowledge we required, minimum machine knowledge, machine learning knowledge required. All right. And then if you're good at code, still you cannot be an AI expert, guys. So if you're good at code, that's fantastic. But code with algorithm, okay, and lot of techniques we have, and you need to follow the techniques, then you become a deep learning engineers or neural network engineers or AI engineer as well, guys. I hope I understand. The one who freshers, I would highly recommend, be patient and listen the class. Even though the words or the technologies is very far vast, but still easily I can explain with lot of common examples which we see in day-to-day life, guys. Okay, listen the class and be patient, and I hope you understand one by one, guys, right? So freshers, and the one who non-technical students also, no problem, please listen the sessions, and I hope you can get some of expert of what exactly this is all about, what exactly all about artificial intelligence and deep learning neural network. So deep learning and neural network is part of artificial intelligence, AI. Are you guys clear? Everybody understand or not up to this? Just I hope we can continue this, guys. All right. Thank you. All right. So let's go ahead and continue to this program. So the first thing, and I want what exactly required, and also I want you to be patient and listen the sessions. And I hope my everything is cleared. And yes, Manu, unmute you. You raise your hands. Any questions, Manu? All right. See, guys, I'll address your questions at the end. No need to worry. All right. Great. Let's minimize. Let's minimize and So the name of the workshop called Workshop on Deep Learning and Neural Network Using TensorFlow. In today's session, let's understand what is deep learning and deep learning framework. What is deep learning frameworks? How to install the TensorFlow, Keras, PyTorch, OpenCV on your machine? How to install these softwares on your machines? And once we understand everything, then we understand what is neural network architectures. And once we understand neural network architectures, we have what is ANN, artificial neural network. In artificial neural network segments, we discuss what's meant by neuron, what is meant by signal, what is meant by forward propagations, what's meant by backward propagations, what's meant by epoch and activation functions. And we do have some of the practicals. I mean, we build some of the customers' churn predictions for banking domain using TensorFlow and Keras. And another practical we have for fashion MNIST dataset training using TensorFlow and Keras. And this is one part of the artificial neural network. And let's another part is called CNN, convolutions neural network. What is convolutions? What is max pooling? What is flattening? What's fully connected layer? When the datas are images, videos, I mean, we'll mostly talk about images because in today's sessions, if I explain all those things, it take more than 5 hours. So we have some limited time frame. So in the time frame, I trying to cover as much as possible in a basic layman technical English term. So I would request you to please we can successfully complete and understand this one. When you understand, it could be fantastic, guys. Everybody's clear? Good. So this is what agenda for today's workshops. It's very clear. So what we done so far, I give you a little bit my introductions and pre-quagist. Okay, so anybody can understand this. It's not that it's not too vast that you can't do this. And also, as I said, the minimum knowledge required, even though you are Python developer, okay, and you never learn how to understand machine learning? To understand machine learning, I want you to enroll my classes, and also those things you get back to later part from the admins and everybody, guys. All right. So clear. So today's agenda, we discussed 6 points today. So the first point is what is deep learning? What is deep learning framework? Machine learning framework is scikit-learn and deep learning is TensorFlow. Installations of TensorFlow, because I will tell you, a lot of students are tough to install TensorFlow library, Keras library, PyTorch, OpenCV. And if you do not install these libraries, your machines never think like a human being, guys. Your machines never think like a human being. So today, first, listen, we will cover this is the first topic, how to installations, and then we talk about neural network, and then we cover neurons, signal, forward propagations, backward propagations, epoch activation functions, and then we heading towards CNN. Let's see, based on the time, we can, whatever time allows, we can go ahead and let's continue this. The first one is what is deep learning. Let's understand, guys, deep learning. So one moment, slideshow from. Okay. So deep learning is a method or technique AI that teaches computers to process data in a way of human brain. So the way human brain thinks, the same way, guys, Bhuvanesh, unmute you. What happened, buddy? Any question? All right. So let me tell you guys. So deep learning. So when it is one of the part of the AI that teaches computers to process data in a way of human brain does. And deep learning models can recognize complex patterns, that means pictures, text, sound, and other data to produce accurate insights and predictions, guys. Understand? So deep learning is a collections of neural network, and these neural network helps to simulate the behavior of the human brain. So normally how the human brain thinks, how the human brain, analyze the situations, those things, if you plant with the machines, now the machines can act like a human brain, guys. So those things we called as deep learning. Understand? And what is neural network? And I can say deep learning is collections of neural network, and these neural network helps to simulate the behavior of the human brain. So we have three neural networks. One is artificial neural network, one is convolutions neural network, one is recurrent neural network. Understand, guys? So let's club up what is deep learning. Deep learning is a technique that learns features and tasks directly from the data, where the data may be images, text, or sound. I hope understand, guys. So the first point, deep learning. In the deep learning, when I train the data to the machine, okay, and the type of data are images, text, speech. I understand, guys. So what is human brain does? Human brain easily understand which image is this, which video is this, understand when to happy, when to sad, all right, and when to cry, what is the emotions, all those things is done by human brain, guys. So let's try to educate and let's try to make system to understand like human. And this is one of the technical part of human intelligence versus artificial intelligence. So that's where human brain versus artificial brain. I hope understand. And to do these things, to system, to machines understand, we need to install some of the packages, guys. And those are packages, or I called as a framework. Packages or framework. What framework we have? The very important one is called TensorFlow. So this is not kind of, as I said, you need to be a little bit exposure on all this technique, and then you understand. So how to, so let's go to the next one. So what are the next point is, just one moment. Okay. So deep learning framework, TensorFlow. What is a deep learning framework, guys? TensorFlow. And also I'll show you some of the frameworks like, we have these frameworks. It could be structured of a system building a project. What is framework, guys? What is mean by framework? So framework can refer to a structures. It could be structured of a system or building a projects. It would help use help to developers in designing products, guys. That means in deep learning, you don't need to write a very big level of code. The moment when you import these frameworks, the code has to be very minimized. The developer also has to write less code. These frameworks provide infrastructures that has already figured out of low level details and allowing developer to focus on specific projects, guys. And we have multiple of frameworks like TensorFlow, PyTorch, Theano, Scikit-learn, Keras. And today we understand all those things, how to install the frameworks on your machines, and I'll share all the document as well. Just follow me, and I'll explain step by step. Then you can install the TensorFlow, guys. All right, guys. Now the first step. So the first step, let's focus. Let's minimize, and we'll go ahead to one by one. So the first thing is, I'll mention framework, which is called TensorFlow. So I can say steps to install TensorFlow on your machines. So follow these steps and I can explain. So the first topic we covered, what is meant by deep learning. And the second one is steps to install TensorFlow. So the first step, open Anaconda prompt. This is the first step, guys. So what is meant by that? Let's minimize, and I'll open, click this one, Anaconda prompt. Understand, guys? And also I mentioned all these steps. Please follow these steps. Even the freshers, non-technical students, they can also install this step, guys. Understand? Anaconda command prompt. And then you can, the second step is, this is what Anaconda prompt. Let a little bit big this one. And I can say that what is the second step? Conda create. So this is what you do. As I already created, conda create, okay, and just one moment, let's copy and so I already created. So what you do, you can conda create TensorFlow environment. I mean, this is not environment. We already remove existing. No, as I already done. So it's not required, guys. Once you do this, second step, in Anaconda prompt, you can install this. The third one. Once we do this, remember your cursor is at base. Which part, guys? Base. Did you see this? We have at base. Base means root. And now when you open Anaconda prompt, you must be notice you are at base. So base means that is root. Base means that is root. And then you can type this one, conda create TensorFlow environment, guys. And the third one you can do activate TensorFlow environment. Understand, guys? So what you do, I can say activate TensorFlow env. That means if you notice, did you see the base will shift to TensorFlow env? Are you guys understand? Now the in command prompt, if you want to go back to base, then you can activate, then you go to base. I mean, look at this. If I want to come back to TensorFlow, great. I hope understand everybody up to this. So the first thing, open Anaconda prompt. And you must be notice the base root is here. The base root is here. And then it's conda create TensorFlow environment. And then you activate this. And the fourth one, you must check base has been changed to TensorFlow. Base has been changed to TensorFlow framework, guys. Clear up to this? Now the second one, before you go back, and then the fifth step is, please open Anaconda Navigator. Open Anaconda Navigator. So how to open Anaconda Navigator? Let's go back. I'll open this one and click it here and open Anaconda Navigator. Guys, if you can hear me, does my voice is clear, then you can give a thumbs up. All right. And I hope everybody understand, does my voice is clear and everything, guys? Okay. I said thumbs up. Okay. And yep. Okay. That's good. That's good. Okay. Great. One moment. I just said it will take minimum 2 hours to 2.5 hours, guys. Please, I mean, okay, you focus on the classes. Once we done, did you see we open Anaconda Navigator? Now the fourth step, please open Anaconda Navigator. Once you open, you can see here, just one moment. Did you notice here we are at base right now? So we are at base, isn't it, guys? Base means root. And once you create a TensorFlow, just click this here. Once you click it, did you see TensorFlow environment or not, guys? Did you see TensorFlow environment or not? Now let's click this. That means your Anaconda also been changed to TensorFlow. It's not environment. I just rename it. You can also make it to TensorFlow and all those things. Clear? We've been done. Okay, not required. Now here, please open Anaconda Navigator and change base to TensorFlow, guys. Once we done the sixth step is the moment when you install, if you installed Anaconda on your device, you might see only one file of Jupyter and one file of Spider. So just one moment. If you open this, go back to this one and Anaconda, the moment when you install first time, you can see only Jupyter notebook and only Spider notebook, but you cannot see Jupyter notebook. And today we need to create this all the deep learning code, all the neural network code, all the advanced code we're going to build on this, applications, not this one, guys. So that's why how to create this one. Now, when you do the first thing, let's have a look at it. And if you install Anaconda for the first time on your device, you see only one file of Jupyter and one file of Spider, isn't it, guys? Now the seventh one, what we do, and then you can go to Anaconda Navigator and make sure your cursor is pointing towards like TensorFlow only, and then click on Jupyter and then go to setting. One moment, just go back to here and scroll down, notebook, click to the setting and install specific versions, guys. I hope understand. And install specific versions. Just one moment. Install specific versions. Did you see? We have these versions, right, guys? And I want you to install these specific versions, guys, which versions you're using. But make sure this version should be compatible with old one. So go to Jupyter setting and install specific versions. Understand, guys? And the same way, 8 point Anaconda Navigator, and then click pointing toward TensorFlow. It's by default, it will be there. And then go to Spider and then setting and install specific versions. I mean to say that, just go back to here and then we head in toward Spider and then install specific versions. As I installed 4.1.3, you can also install these versions, guys. Let's just go ahead and do this. Clear. After installations, ninth one. After install Jupyter and Spider, TensorFlow, I want to open your Anaconda folder. So you will get two applications is created. Two applications will created, guys. I mean to say that, just minimize. Once you, let me close it. It's done. Yes. So once we close it, let's minimize, go back. And if you see this here, did you see, forget about this because I have created many, applications. So you can say Jupyter TensorFlow. Let's open this. And this is called TensorFlow. That means all the code we are going to apply from here, guys. Understand? If you see this, I will get back to the applications, how to test it and all those things. I'll 1 second. I'll close everyone and then I'll close everything and then I'll explain once again. Team, everybody clear up to this? These steps, I hope you follow. Do you want me to repeat again? Do you want me to repeat again? Okay, guys. Do you want me to repeat again? I mean to say that up to this, everybody's close. I mean, clear. So what is the first step? So today's sessions, we started with what is deep learning. What is deep learning? Deep learning is a technique of AI where the input data are images, text, speech, and all those things, guys, right? And then, and then to machines understand, we need to install some of the packages. Then only I hope understand, guys. Then only your machines understand it is a, it's one part of the AI techniques as well. Now, the second one, steps to install TensorFlow. How to install the TensorFlow? This is very important, and please follow these techniques and you make your system to more, you can install these frameworks on your machines, guys. The first one, open Anaconda prompt. As I said, just quick. And I'll open this Anaconda prompt, this one. And once you open the Anaconda prompt, just second one, you can type this conda create TensorFlow. Once you create conda create TensorFlow, it will be create. And make sure you are at base Once it is base, activate to TensorFlow. That means when you type activate to TensorFlow, your route will change to TensorFlow route now. Understand? And if you want to come back to base, then you can mention activate base. So it will activate TensorFlow to base once again, guys. Now the next one. And once you do this, please open Anaconda Navigator as I showed right now. Once you open, change the base to TensorFlow. Akhil, what happened? Any questions, Akhil?
No, sir, it's fine now.
Okay, thank you. All right, so so once we change base to TensorFlow, you open Anaconda Navigator. Once you open Anaconda Navigator, change to TensorFlow, base to TensorFlow, and then you can install specific versions, Anaconda Navigator, TensorFlow root, and Jupyter setting, install these versions. Once you install all these versions, go to Anaconda folder and you get two applications which we created. And this is what we can see this now. Clear up to this? Next one, look at this. We are at not base, we are at TensorFlow root now. So in TensorFlow root now, please install the 10th one. Please install all the applications, all the framework now, all the packages. What are the packages you will install? Keras, OpenCV, PyTorch, and whatever you know, like scikit-learn, sklearn, and then NumPy, and then SciPy, and then we have pandas, and then we have matplotlib. You need to install everything as well. So here, to install these Keras, this is very important. If you do not install proper, then it could be trouble a lot of things, guys. So very simple. Pip install Keras 2.3.1. Let's go back, and might be the main problem which you face is you get some of the installations issues, guys, over here. Maybe some of the versioning is not supports. For example, if you install Windows on Mac laptop, it's not works out, and the versioning also important, guys. So how to install the, you need to check, because we how many versions we have Keras, and I want to go back and you can check this out, and the latest versions you can find out everything. Keras latest versions, we are at 3.7, and you can also activate the 11th one. Okay, please install pip install Keras. If you want to upload any versions, you need to put the versions name 3.7, or you can say 3.6 based on your compatibility, based on your compatibility, system compatibility. I hope understand everything. And then pip install is done. And how to install pip sklearn? Pip install sklearn, and then everything pip install numpy. As I already installed, pip install numpy. As I already installed, I think it will display as pip install sklearn. As I already installed, so it's a requirement already satisfied. But when you do the first time, it will take some time to install all these frameworks, guys. Now the next one, how to install PyTorch. To install PyTorch, I want you to keep this one, pip install and HTML. I already installed in my machines. Let's copy and 13th one. This is for Keras package. This is for NumPy and etc. etc. Okay, and this one is for 14th. This one for PyTorch. What is meant by PyTorch? I mean, this is one of the very important applications, and Torch applications also you can install. And then you can install basic library, sklearn, NumPy, pandas, all those things. And I can say this is install basic library. And based on system, this is install Keras library. And this is we called PyTorch library. Clear up to this? I hope everybody understand up to this, guys. Oops. 14th. Okay, so once we done this, what is the next step? How to install OpenCV as well. So how to install OpenCV? We have okay, few things. Check in notebook, all those things is done, guys. You can also pip install OpenCV. It would be done as well. All right. So here, let's copy, and this we use for OpenCV. Clear, guys. Successfully install all the TensorFlow installations on our device. And once we done, let's test it whether, let's test whether the TensorFlow is installed or not. So how to test it? 16th one. So how to test it? Just go back and we can check this one. And all this application is done, and you can exit this, close. Once we exit, let's minimize. Once you have go to start options. If you open now, you create two applications. This is one applications which we built from the moment when you installed Anaconda, and second applications we created right now, which is called Jupyter Notebook TensorFlow. Now I will open both. Let's check this. This is normal Jupyter, and let's close this one. Let's minimize. And once you do this, TensorFlow environment. I'm in two kernel. Let me open. It will take some time. Just 1 second. Great. Did you see two file is opened? Now, if you open two file like this, just go ahead and new Python 3. And this one also new Python 3. So let's open. Let's understand which is our TensorFlow window, which is our normal Jupyters, where we go for data analysis work, machine learning work. We can use on normal window as well. So how to do this? You can test at least like, okay, let me increase the font. It's better now. Import TensorFlow STF. Okay. Shift enter. Let's check this. I hope, did you see the kernel is blink? That means the let's wait for some times. Perfect. This is called our TensorFlow kernel. And when you check this, you get error. What do you mean by that? That means all the deep learning programs, codes, and neural networks or models, we're going to build on this framework rather than this work, because this is not going to work. This is not going to work, guys. I hope you understand. I hope understand. And to check this, how to check the Kira's installed or not? Let me tell you guys. I want you to I shared this PDF to you so that you can understand and how to check this for the Kira's. And I want you to use this one as well. And I can say, 1 second, guys. Image data generator. Okay. As we come to know, from keras.preprocessing.image data generator, let's execute this. So in this, always remember, in deep learning framework, TensorFlow is backend and Keras is front end. So here, let me mention this one. In deep learning framework, which is backend, guys? TensorFlow is backend and Keras will be front end. Keras will be front end. I hope everybody clear. In deep learning framework, TensorFlow would be backend and Keras would be front end. Now, to test the TensorFlow, what we done right now, we checked both import TensorFlow STF. If the code is executed, that means successfully we installed TensorFlow in the machines. Now, again, you must need to check, you must need to test whether Keras also successfully installed or not. So how to test this? You can use this one, as I said, from preprocessing, because you can find out a lot of informations, image data generator. I can also, you can find out from the some of the important article from the Keras library. Okay, and preprocessing images, we have image data preprocessing, all the images, whatever the images we load to the data, and that has to be come from this Keras framework, Keras library. So I want you to test very well whether this installed in your machines properly or not. And then once it is done, you can also have a look at this, guys. Have a look at this. I do understand sometimes you feel the session is a little bit advanced, guys. So please stay with me. I hope the one who already enrolled, you get to know a lot of things in upcoming classes, and it's no need to worry for you. Okay. And then here TensorFlow is back, and that means the Keras is successfully installed here. In this case, we installed Keras, we installed TensorFlow. Fine. All right. And then close this. You can also check this import CV2. Now shift enter. This is for OpenCV. This is for OpenCV. Team, I hope understand. So today we discuss, let me close everything. Today we discuss, and the third one, 19th one is import CV2. This we use for OpenCV. Now you can also test this, because all of the basic library also, all of the basic library also you can test, like NumPy and Matplotlib and Seaborn, all those things we've been done as well over here, guys. You can also test this. Now, final step is 21. Successfully, we are completed TensorFlow and Keras. So far, we done two part till today. And in this workshops, we started, what exactly we started? I done my basic introductions, we done. And if you want to need more detail of mine, please visit to LinkedIn as well. I told you. Second one, what is deep learning? Deep learning is one of the AI technique. AI has many techniques, okay? So deep learning is one of the part of it. And in deep learning, we understood the images are text, images or numbers as well. To take care of all those things, we go back to the deep learning. We understand that one. And to build deep learning projects, to build, and also I can say deep learning is collections of neural networks. And then to build deep learning projects, okay, we required frameworks. We required frameworks. What are the frameworks we have? TensorFlow, Keras, and all those things we installed. Second one, we installed TF, Keras, OpenCV, and PyTorch, and basic library. And finally, we installed TensorFlow, successfully installed TensorFlow, guys. Okay, everybody clear up to this or not? Everybody clear up to this? Anybody have any questions so far? You can raise your hands, I'll unmute you, we can speak. And then we get back to the another part. Great, I hope understand, guys. Excellent. Okay. The moment when you do, you can understand, or else it would be a little bit, no problem. Now the next part is, as I said, two participants raise your hands. Okay, I cannot find you guys in the chat window. All right, so let's go ahead to the next one. As I said, deep learning is collections of neural network. In the neural network, we have two concepts. I mean, what are the neural networks? We have the first one is called ANN, artificial neural network. What is the first one, guys? Artificial neural network. So let me close everything, and 1, 2, 3, 4. We close this. Let's close. Let's close this one, and I will close this one as well. Kernel functions also. I'll close this. Great. Now I'll continue to the PPT. We install TensorFlow Keras. Now the next one. What is neural network architecture? So the first thing we understand, the architecture of neural network is made of input, output, and hidden layer. Guys, I'll give you one examples as this is quite interesting, like neural network architecture. So as I said, collections of neural network. Let's understand what is neural network architecture. So the first thing is, in neural networks, what exactly we have, guys? In neural networks, neurons are there or not? So entire human body. So let's say I can mention as human neural network versus artificial neural network. So let's understand what is meant by human neural network. So this neural network system created by God, isn't it? What is meant by that? Let's assume if you stand somewhere, let's say mosquito bite on your left hand, mosquito bite on your left hand. So immediately the neurons are activate, isn't it, guys? The neurons is activate. When the neuron is activate, it pass the signal, and it pass the signal to the brain or not? It pass the signal to the brain. So in the brain, again in the brain we have activate the neuron, and that from the brain it pass the signal to the right hand, and right hand is do the performance like please do some, I mean, actions because it gets hurt. I hope understand, guys. So what happened? I just said if mosquito bite on your left hand, the neurons is activate. Which neuron? In left hand, the neurons is activated, right, guys? And then everything we see from the eye or not? Everything we see from the eye, yes or not, guys? I mean to say that let's create a architecture. Now let's say we have neurons. Okay, let's assume we have many neurons, guys. Let's 1, 2, 3. I hope understand this example. What exactly examples I'm given? If you stand somewhere, if mosquito bites on your left hand, everything you can see through eyes means you taking the input layer, you taking input data, and then the immediately the moment when mosquito bites on your left hand, the neuron is activated, pass the signal to the brain. From the brain it pass the signal to the right hand, guys. So I mean to say that the moment when we take the informations through eye can be called this is input layer, guys. Can we call this is input layer? And these are called neurons. And the signal pass once the signal pass to the brain, isn't it? Yes or not, guys? These are the neurons activated, pass the signal to the brain. And in brain also, the brain is activated and it pass the signal to your right hand. And right hand, whether you kill the mosquito or not kill the mosquito, team understand, guys? So this is architectures given by God to us, and when I plant same architectures to the machines, that becomes artificial neural network. So that's why I mentioned these words called human neural network and artificial neural network, guys. So in these examples, everybody can understand what is meant by input layer and what is meant by hidden layer and what is meant by output layer. I hope everybody's clear up to this, guys. So with these examples, everybody understand what is meant by input layer, what is meant by hidden layer, and what's meant by output layer. Clear up to this? So as I said, let's minimize. So that's what we called the neural network architecture is. The neural network themselves or artificial neural networks are subset of designed to mimic the processing of human brain. So in this graph, this is called neurons. neurons. This these three neurons are called input layers. This these neurons are called hidden layer. These neurons called hidden layer 2. This is called output layer. I hope everybody understand up to this, guys, what is neural network architectures. Architectures means we try to understand now basic of the examples which I gave you right now. What is input layer? What is hidden layer? What is output layer? Are you guys understand? I mean, when a mosquito bites on your left hand, we take the data from eyes through eye. So through the eye, it's called input layers. It passes the signal to the brain. Brain is hidden layer and pass the signal to the right hand. That's called output layer. Now, the same way in deep learning also, in neural network also, we have input layers, we have hidden layers, we have hidden layer 2, and this is called output layer, guys. I hope understand. Now, the next one. The first concept is artificial neural network. So let's understand, as I told you, what is human neural network versus artificial neural network. We guys clear. Artificial neural networks usually simplify called neural network of neural nets. ANN is based on collections of connected units or nodes called artificial neurons, guys. ANN is based on collections of connected units called artificial neurons. So do you see the human brain consists of these all concepts, guys, like dendrites, synapses, axon, and each and every neurons are connected to neurons, guys, isn't it? So the brain is consist of multiple neurons, and each node neurons signal process from input. So the same way, as I said right now, if you look at this, guys, so this is called neurons. The signal pass from one neuron to other neuron, one neuron to other neuron, like input to hidden layer, input to hidden layer, input to hidden layer, and hidden layer to another hidden layer 1 and 2. This is, I'll tell you, multi-neural network as well, hidden layer 2, and finally from hidden layer to output. So this entire architecture means network. Did you say neural network? When neurons are connected to one to another, that's called network. So this is one neuron to other neuron, another neuron to, I mean, hidden neuron to output neuron, input neuron to. I hope understand, guys, what is neural network. So guys, this is workshops, please try to understand as a basic, and this is a little bit advances, and I hope many of them explain different way, but the way you guys understand all the concepts clear today. Clear, guys? I hope understand this one. Now let's go ahead to this one. I'll draw it. So just now we discussed what is neural network architecture. What is neural network architecture? Are you guys clear up to this? Fantastic. So here we understand HNN, human neural network, versus ANN, we covered. Now the next one is, okay. In neural network, there's two concepts. One is forward propagations and backward propagations. What exactly mean by forward propagations? What exactly mean by backward propagations? Let's plot one diagram, and let's assume I will give a small data sets right now. And in this one, okay. So let's say a student play for 2 hours and student study for 4 hours. Okay. And a student sleep for 9 hours, and when he write the exam, he pass the exam. Pass means 1, fail means 0. The data is binary. Okay, so I can say the student pass the exam means 1 and fail the exam means 0. As I said, this is advance of machine learning. If you understand machine learning, that's fantastic. If you're not, no worries. If you never been into AI before, data science before, please watch out the other workshops as well, which are conducted by me. So I hope you can follow this, guys. So the student pass exam or fail exam. So how many attributes I have? I can create a 3 neurons like pass, I mean play. This is playing. Can I say x1, x2, x3, and student pass the exam or fail the exam? This is called dependent variable. So we have independent variable. Let's plot x1 here, and let's plot x2 here, and let's plot x3 here, guys. So now let me tell you, I wanted to tell you one thing here. I have one data set. In this data sets, students play for 2 hours, which is x1. Student study for 4 hours, which is x2, and the student sleep for 9 hours, and he write the exam, he failed the exam, or maybe he failed the exam means 0 and passed the exam means 1. So 1 and 0. So the data is binary and the data is continuous. I hope most of them knows about this. If don't know, just no need to worry. So here, this is called, can be called input layer or not, guys? Input layer. This is called input layer, guys. Are you understand? What is the architectures? The architecture is we have one input layer, hidden layer, and output layer as well. I hope understand. So x1, x2, x3. So once we pass the signal from x1, this is called hidden layer, and hidden layer I can call x4, and model predicted is called y hat. So I hope most of them understand what is actual data, what is model predicted data. So y is called actual and y hat is predicted. So this is, you must need to understand in-depth skills, guys. So the here, so what I said, x1, x4, y hat, when I pass signal from input layer to hidden layer, some weights are generated or not, guys. Let's assume I generate weights is w1, and let's w2 and w3, guys. Are you understand? So let me tell you, I'll give you some of the examples. I hope understand what I'm trying to say. I'm explaining very slowly so that everybody can connect it and understand this one. As I said, in the left hand, there is many neurons are there. The moment when a mosquito bites on the specific portions only, the neurons activated. So the moment activate this neurons here and activate this neuron. So when these neurons are activated, once X1 is activated, pass the signal to hidden layer. What is the weight, guys? W1. So let me tell you what's meant by weight. In the world, there each and every action has weights are associated. For example, 1, 2, 3. What is weight of these records? Assume I have 3 records. 1, 2, 3. What is weight of the records? Can I say 1 by 3, 1 by 3, 1 by 3? Can I say, guys, all these are weights or not? I mean, all the weights are uniformed. So in this case, let's control G, control G, control G, guys. So assume, so here W1, and then once the hidden layer also, the neurons are activated, guys. Once the neuron is activated, we pass the signal to output layer W4. So let's assume the model predicted 1, or maybe the model is predicted 1. So assume the model is predicted 1. Actually, or maybe this is called 0, but actually, see, actual student failed the exam. That's why we called 0. Student is failed the exam. That's why we called 0, guys. But my model predicted 1. So here, y equal to 0 and y hat equal to 1. Is this correct classifications, guys? Is this correct classifications? No, this is not a correct classifications. This is not a correct classification. So what you do? So what you do? So this is called, I mean, this concept is called forward propagations. This concept is called forward propagations. No need to worry, guys. In the sessions, I'll explain in detail the one who enrolled, but try to understand. So what is input layer? What is forward propagations? I hope understand, guys. Did you see when you play the music, you forward the music, isn't it? Or when you see any movies, Netflix, Amazon, you forward it. Means we pass the signal from forwardly, which is called forward propagations. Now, if you see this one here, if you see this, if you see this graph, this is called feed forward, means we pass the signal like this way. This is called forward propagations. I hope understand. And as I said right now, so I have two neurons, and this is a hidden layer. This is output layer. Now, once I pass the signal, and my model predicted is 1, actually it is 0. Or else you can say that, or else this is actually 1. So what we do, this is forward propagations. And this is y, y hat, this is called y, means 0. Now, do you know there's a loss functions are there or not, guys? What is meant by loss functions? Loss functions means actual minus predicted. Loss functions means actual minus predicted. What is actual here, guys? So here, actually, student, student failed the exam, guys, right? Actually, student, or maybe I can say actually student passed the exam. This is called Y. But my model predicted failed the exam. That means this is no. That means this is Y hat. Y hat. And in the Y hat, what is loss function? Loss function's formula equal to actual minus predicted, guys. Actual minus predicted. Now I do understand a little bit. I hope if you understand, then that's fine. If not, I'll do it once again. Let me write it down just quick, and then we plot the code now. So here I have, let's plot this one. Student study for, play for 2 hours, and study for 4 hours, and sleep for 9 hours. His result is pass. Let's assume his result is pass, guys. And I create 3 input neurons, and we create 1 output. I'm sorry, hidden layer, and this is called output layer. So we pass the signal. We pass the signal. When we pass the signal, what happened? This concept is called forward propagations. This concept is called FP, forward propagations, and my model predicted is 0. But actually, the student pass. So this is called y hat. This is called y. So do you see what is the loss functions? Y minus y hat. So y minus y hat means what, guys? 1 minus 0. So that means that's why if you do the back propagations, let's see, this is called x1, x2, x3, x4, and y hat. And now I have weights are w1, w2, w3, and w4. These are the weights. The moment when a signal pass from input neurons to hidden neurons, weights are generated. The moment when signal pass from hidden layer to output layer, the weights are generated. As model predicted, student failed the exam. That's not correct. The misclassifications happened here. So that's the reason we trying to do a back propagations. When you do the back propagations, what happened, guys? 1 minus 0. So when you go back to the back propagations from output layer to hidden layer, the W4, would it be same weights or different weights, guys? The weight will adjust. The W4 will change to W4 new, and this one changed to W3 new, and this one changed to W2 new, and this one changed to W2 new. So the moment when backward we adjust the weight, this concept's called back propagations. And back propagations weights are adjusted, guys. So the new weight is equal to, I'll show this one. I hope understand this part, guys. So let me mention this one. So let's go ahead to the slide. Great. So that's what I mentioned. This is called neurons. What is forward propagations? Forward propagation is the way data moves from left input layer to right in the neural network. A neural network can be understood by a collections of input and output nodes. What is back propagations? So back propagations is the process of moving from right to left. Very simple. What you say, guys? I can call it as you forward the music, backward the music, reverse the music. Do you notice when you forward the music means you can all do these things, guys? Backward the music. So this is called forward propagations. This is called back propagation. So just one moment. Sorry, I'll plot some of the graphs here. So let's do this one moment. As I said, this I have neurons. I'll plot this one, x1, x2. This is input layer. This is hidden layer. This is output layer. I'll plot this is x4, output layer would be y hat. And What kind of propagations we call, guys? This is forward propagations. This is also forward propagations. And the weights are generate W1, W2, and W3. At output layer, every time the neurons are activated and the model predicted, this is called zero. This is called zero. What happened, guys? Student fail, but actually student pass. So what you do, that's why we do the back propagations. That's why I do the back propagations. When you do the back propagations, the W3 will rename to W3 dash. I mean W3 hyphen or W3 new. I give you one of the example. From hidden layer to input layer, this would be changed to W2 new. And from hidden layer to input layer, this will change to W1 new. Can I say one iterations, guys? What is meant by one iterations? One forward propagations plus one back propagations is called one epoch. I hope understand. One forward propagations, one back propagations called one epoch. When we do one epoch, what happened? The way W1 has changed to W1 new, and W2 has changed to W2 new, and W3 changed to W3 new. Let's do the forward propagations once again. And what exactly happened? The model predicted 0 to 0.4. In the first epoch, the accuracy 0 to increase to 0.4. Understand, guys? I hope clear. And what exactly? Actually, student pass exam, but my model predicted 0.4. Now, what you do? Can we do again back propagations? In the back propagations, once again, W3 new become W3 new one, W2 new one, W1 new one. And this is called second epoch. In second epoch, what happened? When you do forward propagations once again, so this 0.4 will increase to 0.9. And what happened, guys? Did you see now model predicted 0.9? Actually, student is passed, means my model predicted 90% student is passed. That means this is the way we increase the accuracy of the model in the deep learning methods, guys. So this concept is called epoch. So no need to worry. So in this one, I'll understand what is forward propagations. Back propagation is the process of moving right to left, and forward propagation, we can adjust the weight, guys. I hope understand everyone. Now, go to the next step. As I said, activation functions. Activation functions is very important. So we discuss here one moment, guys. Forward propagations. I mean, signal pass from left to right, and backward propagations signal, I mean, from right to left. But in this case, when the exactly weights are changed, weights are adjusted from right to left. I mean, adjusted at back propagations, guys, at back propagations. Are you understand up to this? And I can say one FP plus one back propagations is called epoch. So what we understood, as we do many epoch, as we do many epoch, the accuracy will increase or not? The accuracy will increase. Are you understand, guys? So that's why I'll show you practical also. I will show you practical how to do this, how to assign the epoch. I'll show you practical how to assign the epoch, guys, right? So just, and how the accuracy is, and let me talk about activation functions. This is very, very important. We have many activation functions, but I just wanted to tell you one thing, guys. As I said, loss functions. Just now I gave you one diagram. We have many loss functions we have, guys. So we have regressions loss and classifications loss functions. In regressions loss, we have MAE, mean squared, MAE, MSC. You guys understand? I mean, loss functions, we have MAE and And loss functions, we have optimizers called, that's what I said, gradient descent and SGD, stochastic gradient descent, and batch gradient descent. And this is called also optimizer, Adam optimizer, and add a grade and add a delta, all those RMS prop, all those things practical will use this, guys. Are you understand? So this is, I mean, we have many more loss functions and we need to implement all these loss functions in practical. Activation functions, this is very important. This is very important, guys, these activation functions, guys. Theoretically, I'm explaining you now, but after sometimes once we complete it, I will explain practically as well. So how we build the activation functions in our TensorFlow framework, which we created right now. And we're going to do the practical as well. But before that, let me complete few of the concepts, which is very important. And this is very in-depth concepts, but as this is a workshops, I do understand some of them, well aware of all these things, and some of them, if you don't know, please listen the first time. And this is, if you learn this technology, the package is very high, guys. AI engineers and deep learning engineers, neural network engineers, convolutions neural network engineers, the packages are quite high compared to other developer, because you need to be learned a lot of things from here. Okay, activation functions. What is mean by activation functions? As I told you, when a mosquito bite, the neurons are activated. So here in deep learning, any neural network, deep learning, we have few activation functions. And what are those? I will show you all those things, which is called threshold, sigmoid, tanh, relu, leaky relu, softmax. So how much activation functions we have, guys? And we have activation functions. The first one is called threshold, and second one is called, sigmoid, and the third one we called relu, and the fourth one is called leaky relu, and the fifth one we called tanh, and the sixth one we called the softmax. I mean, this we used for binary class, this activation functions used for binary class classifications, and this one also used for binary class classifications. Binary class, what is meant by binary class? True or false, yes or no, that is a cat, that is a dog, okay, sad or happy, all those things, guys. So this is called binary class classifications. Softmax, this we used for multi-class classifications. What is meant by multi-class classifications? If I compare the dogs of entire world, India dogs is cannot similar with, US, UK, African, all the different type of classifications we have, guys. So this is not multi-class classifications, guys. In here we'll implement probability distributions graph. We can plot distributions graph. As I don't want to explain each and every activation functions right now, but I'll tell you a few things to go ahead and understand the practical. I will explain relu activations functions right now, and then sigmoid functions we can understand. And then we go ahead and directly jump to the practical, and we can start how, the way just now I said, the examples, mosquito examples. Let's build the same architectures in a program and we can define it, guys. And here we go. But before that, what is sigmoid functions? The sigmoid is, I mean, before you understand sigmoid functions, you must need to understand logistic regressions. In logistic regressions, you need to understand the math concepts. And also this is logistic regressions, also called as logit or maxent. This is we also called as probability algorithm. And we get the formula as 1 plus e to the power minus x. So those things, that's what I'm saying. A little bit, this is advance of these things, and I hope understand. And sigmoid curve generate from, okay, to handle outliers, and the range of sigmoid curve is 0 to 1. So what is 0? 0 means student failed, as I said, and 1 means pass the exam. Guys, are you understand or not? So that's why these are the activation functions. And sigmoid, how many layers we have? We have input layer, we have input layer, and we have output layer. Just one moment. We have input layer, we have hidden layer, and we have output layers. We have 3 type of layers, guys, isn't it? Why can't you? Any questions, guys? No, somebody? I hope it's clear. Now we have 3 type of layers. We have, as I said, input layer, hidden layer, and output layers, isn't it? So student pass the exam or fail the exam as we discussed. Now this is one of the activation functions, and another activation function is ReLU. So ReLU means, if you follow this, the sigmoid functions curves look like S shape. If you see this, did you see this sigmoid curve looks like S shapes, guys? And what we do, these functions reduce extremes values of outliers and the data spreads ranging between 0 to 1, 0 to 1. Understand? And another one, which is called sigmoid and ReLU functions. ReLU functions is mostly wide usedly in activation functions. And look at the formula of max of x comma 0, max of x comma 0, guys. So when we pass max of x comma 0, can you tell me what is maximum value of minus 8 comma 0? What is the maximum values, guys? Minus 8 comma 0. So the max value is 0 itself. The max value is 0 itself. So here, let me tell you the range of ReLU activation function is 0 to infinity. And that's why most of we apply these activation functions, we apply this activation functions at input layer always and hidden layer, guys. The reason why, just go back to this one. If I plot the input layer, if I plot the hidden layer, this is output layer. We pass the signal or not? When we pass the signal, from the signal, we have to pass maximum value. And then we get back to the hidden layer, guys. Then we pass to the maximum value. Then we get back to the output layer. I hope understand you. Everybody's clear? So we pass the maximum value to output layer, maximum hidden layer, and output value. So where do we use, guys, these ReLU functions? ReLU activation functions we will use input layer and hidden layer. And same way, sigmoid activation functions always we will implement at output layer, guys. Sigmoid activation functions always we will implement at output layer. I hope understand. And softmax activation functions we will use when the data is multi-class classifications. Okay, multi-class classifications. So softmax activation functions we will use when the data is multi-class classifications. I hope understand. What is epoch? One forward propagations, one backward propagation is called one epoch, guys. I hope understand, guys. So that mean to say that, just one moment. Let's minimize. Okay, let me do final. What is epoch? Forward propagations plus back propagation is called one iterations or one epoch. Weights are adjusted at back propagations. This also called as back propagations of error. So back propagations in deep learning. As I mentioned, if the study at 12 sleep, the exam is 93%. We have 3 neurons, X1, X2, till. And what is the formula? Weights are generated W1, W2, W3. And then we pass the forward propagations. And what happened? Y and Y hat, the cost. What is cost, guys? Difference between Y minus Y hat is reduced. So using forward propagations, and look at this arrow mark. This is forward, this is back propagation called epoch. So this concept is called back propagations in deep learning. Now, last step, before I go ahead, one practical, and then we understand. So back propagations in deep learning. What is epoch? As I mentioned, so how many epoch we done in this graph, guys? 1, 2, 3, 4, 5, 6, 7, 8. Now listen to me. In the first epoch, the accuracy was 93 percentages. And actually, this is 78, 93. Did you see we have error or not? This is y minus y hat, cost functions or loss functions. We call these guys. We have this error. And this one, y minus y hat in second epoch, the exam accuracy is reduced. And this one, so y and y hat should be equal. So finally, at eighth epoch, the accuracy is 97% this guys. So did you see these epoch is very important, and I will tell you how to do this same system, how to set up in code. Let's do this guys. And before that, I wanted to talk about this one. There is a one project called customer churn predictions. Customer churn means customer who want to stop to use the product. And I have some of the customers informations like ID, name of the customers like Akash, CIBIL score and state, age, tenure. So a lot of customers, many bank account guys like Citibank, like ICICI, like SBI, like ICI, I mean, Central. So keep bank customers are keep change from one bank to other bank. So let's say I'll give you one small situations here. Let's say there's a customer called A. He used SBI Bank, and after 2 years he quit and he go to ICICI Bank. That means to for a SBI, it is a loss or not? Definitely it is a loss. This is called customer churn from one to other guys. Even if you talk any telecom industry, in telecom industry, if you use Zio SIM and after that you can do not use Zio and use Vodafone now, then customer churn for Geo. So being a data scientist, you're trying to predict the factors. What is the probability factors? How much customers they're trying to churn in next year? How much probability the customer churn to do the next year? So I mean, this projects for banking domain, and to build these projects, we used few customer historical sample records. We use customer sample records. Each and every customer's detail is called as a records, guys. And we build deep learning models in historical data, and we'll see the model accuracy. And after that, I'll talk about one of the projects called Fashion MNITs, how you build the projects using TensorFlow, and we go ahead and do this. So the first thing, let's open one of the data sets, and the next one, let's do the practical now. Let's do the practical now, guys. I hope understand. So in this practical, what we understood, we have one of the data set. Just one moment. Let's open it and I'll create some of the workshops, deep learning. Okay, so this one here. Okay, so here we go. So these are the customers' informations we have. And if you notice this, so this is ID, customer ID. I mean, customer name Akash, and every bank has CIBIL score 619 and state Bangalore, and age of the customer is 42, tenure 2 years in the bank, and his bank balance is 0, number of product is 1. Number of product means, let's say you have debit card, credit card and business account, and maybe business loan. All this called as a product as well. Business loan is one product, home loan is another product, personal loan is another product. You can say number of product is 1. Does the customer is credit card? Yes. Is active member? Yes. And his salary is this much of salary, and customer exit or not? Customer is exit. You understand? So this is some of the historical data, and based on historical data, we try to build the model in TensorFlow, and model will recognize what would be the future customers. I'll show you all those things. Just we have in this data set, the data stored in the locations, guys, isn't it? The data stored in these locations. So I want to work this using my Spider TensorFlow. Let's open Spider TensorFlow. One moment. Okay, that's great. And this is the web platform. I will tell you how to change all those things. Okay, this is called Variable Explorer. And by default, when you open Spider, it will gives you what is the time and how to work on this. Let's minimize. And let me start, let's start these things like import numpy as np, and I will a little bit split the screen so that everybody can work on it. And as I said, we try to work this program on TensorFlow, not in what, guys, normal this one. And import pandas as pd, right, guys? And then I can say, let me check this, done. You always see the output over here. This screen is output. This is called Spider. In Spider, you can write all the code in this sections, and you get all the variable explorer, whatever the objects you created, you can find out here, and all the code executions you've been done. Any bug, any error, you can find out in this sections, guys, right? Now let's go back, import numpy as np, import pandas as pd, right? And then I can say import TensorFlow as TF, all right? Import TensorFlow as TF. Now let's go ahead and check this out. Okay, fantastic. I hope a little bit zoom so that you can see the screen as well. Did you see the code is still running? So that's why it's done now. And I executed NumPy. I got this. TensorFlow pandas is not done. Let's go ahead and done this one. Pandas also done, guys, right? And the next one, this is the basic libraries which we need to import in each and every times to get to visualize, to do these things and create a framework, create a multi-dimensions array. And then I wanted to know what versions I'm using, tf dot versions. When you check this, okay, let's have a look at it. You can also, right now I'm using 2.1.0 versions, guys. So because it is installed long ago, so maybe you see your versions might be TensorFlow, so you have updated versions, you can find out, guys, right? Now just understand this one, tier versions is done. Once we do, the first thing, I have data. The first step, I can import the data set from my system to software. And for that, I create an object or identifier. Let's called data set. Normally, data set is equals to pd dot, we have read.csv, isn't it? So because those files are CSV, and then I will, where did I store my files, guys? So I can store the file here, which is called, let's copy, and file location customer exit. This raw string, as it is raw string, I'll mention this one. So I little bit reduce my screen, I'm sorry, so that it would be good for me as well, right, guys? And I can check this. I'll copy my copy, and let's go ahead dot csv. All right, and then let's check this out. The variables are created here, guys. The variables are created. Just go to the data set. One moment. Great. So whatever the data we have, over here, and we can load to the data frame, guys. We can load to the data frame. And look at this, guys. Which is dependent variable? Exited. Customer exit from the bank is yes or no. So that's very important. I mean, the dependent variable is binary. So the dependent variable is binary. That's why we can apply classifications, guys. And how do I split the data from entire data set? If I remove exited, then this becomes my independent, this becomes dependent variable. So that's what, let me close this. Let me close this and I can create as X equals to, okay, I can say dataset dot ilog functions, log and ilog, because it will give you the specific index locations. And once we do this, and I can use which index we have, guys, and 3 2, and I can do this, just one moment. From entire row I can apply -1, just dot independent variables. In independent variables, what exactly I want, but I just wanted to say, to see, to predict, we don't want customer number, ID, and all those things. Name also does not require, so that's why 3. I hope you know the indexing or not. Python index begins with 0, so this is called 0 1 2. I hope everybody's clear, guys. Now the next step is, let's go ahead and once we check this out, X, look at the data set, guys. Okay, and look at the data set. Now what happened? We have the data set. From the data set, this is dependent variable and rest of them are independent variable. As always, remember, we need to build the model with relevant attributes, not irrelevant attributes. So that's why number, ID, name is irrelevant attributes. So that's why I eliminate them from this. And this is called your proper independent variables, guys. This is called proper independent variable. If I check the background colors, clear up to this? Now the next one, let's copy, and same things I can change to Y as well. Or maybe I can say X small x. And one moment, let me restart the kernel. Just 1 second, guys. Let's restart one more time. Great. Execute one more time because I've been make all these objects to equal small letters. So that's why next step is to be interesting. Great. And then TA versions, as we know how to check the versions. I don't. Now let's call the data set. We import the data set, independent variable. This would be independent variable we created. And from this data set, if I remove rest of things, this become dependent variable. So dataset ilog, and I can execute this one. So now look at this, guys. We split the data into, this is entire data sets. I have how many columns? 13 columns. We have 10,000 rows. And I split the data into independent, where we have 9 relevant attributes. And this is dependent variable, guys. Team, understand what we've been done? What we've been done, I hope understand. Let's close this, and let's close this, and let's close this. Now we call the package. These are the packages, and these are the packages, and this is called, we have TensorFlow as we installed today morning. And once we done, we import the data, and this part we split the data set into independent variable, and then we split the data set into dependent variable. I hope understand up to this, guys, right? So this two part is clear. Now the next one, what is the next one? But if you see this data, machines does not understand what is Bangalore, what is Pune, what is Hyderabad, all these locations, right? So your machines does not understand. So I need to impute this. And I hope you know what exactly the imputation technique, so we can encode the categorical data. So if you notice this, which is the index locations, guys, 0 and 1. So 1 is the index locations, isn't it? So one is the index location. So what I'm going to do, I am going to apply as a label encoder as well over here. So I can do this. I can mention what we're doing now. We are imputing categorical data to numerical data. So for that, from sklearn, okay guys, and dot preprocessing, okay, and we import. If you see, we have three techniques, as you must need to know this: label encoder, hot encoder, and all those things, guys. And label encoder, did you see we have, you don't need to use this one, label encoder. What exactly mean by that? Let's take this cursor, and you got some help options. You can also read these help options, what exactly it does. If you see this, encode target levels with value between, it transform the values from categorical to numerical as well. So once go back to this one, and I can, in this independent variable, we have locations, which is category, and I want to change to category. And let's go ahead and execute this one. A little bit check. Okay, perfect. Execution is done. Label encoder. Now, as we see, you can also check this, guys. You can also check dataset.info. Okay. And also you can check and dataset.describe and dataset.shape, and shape how many, how many rows and how many columns we have. You can also find out. And dataset.columns, just check this out. How many columns, number ID, name, civil score, and all those things you can find out as well, guys, right? And then once we go back to the next one, I can say, so I create a object for label encoder, and I'll pass this, just execute, done. And then what exactly happened? We have independent variable. I need to change this categorical part to numerical. So that's why what happened? Did you see what objects we created? X. So that's why X, from X, I can say first copy, and from the independent variable, first index is equals to, and what is labeled encoder or not? le dot fit underscore transform. What exactly, guys, we can call fit and transform. The moment when we apply, you can use X and then comma 1. Let's copy the same things, guys. I hope understand, guys. So I'm using small x. I don't want to mention capital X here. Perfect. Team, I hope understand what exactly I'm saying. We import the data, we split the data into independent and split the data into dependent variable. And then we call label encoder, because we know the three techniques, how to import, how to encode the categorical data. And let's go ahead and check this. Great. So now let's open this one. Do you see, guys? Now, if you open the data set, what happened? So Bangalore 0 and Pune is 2, and rest of things 0, 1, 2. It is imputed or not? Now, if you open the independent variable, we don't have any categorical data. What is the next step? So imputation technique is done. The next one is we can try to do this one, guys, which is called feature scaling. So the feature scaling is very important, because scale the feature is important. How to scale the features? We have feature scaling. What is meant by feature scaling? We have two technique. One is in feature scaling means scale the data. What is meant by scale the data? As you know, let's say if a kid, let's talk a family, the family called A, and the family has three kids, 1, 2, 3. First kid got 10 chocolates, second kid got 3 chocolates, and third kid got 15 chocolate. Do you think all three kids are equal? No. So I need to scale this data. How to scale? If I shared the data to between 0 to 1, between 0 to 1, between 0 to 1, if I shared them one chocolate, this is called scaling. Now they don't have fight among these three kids, isn't it? So the feature scaling, we have two type of technique. One is called standard scaler and one is called normalizer, guys. And also min max scaler also we called it. So for that one, I need to call this features which is called from sklearn.c. We called machine learning in the TensorFlow, right guys? sklearn.preprocessing as import standard scaler, not standard features. I'll use standard scaler, guys. And then I create SC for, let's copy this and I can apply standard scale. What is scale the data? Scale the data between 0 to 1. As I said, your machines does not understand what is customer age, what is salary. Are you guys understand? Because we know very well that what's age of the customers and what is the salary of a customer. And I mean, so those things to make all these data points into equal scale. For that's the reason we need to use the standardizations. And let's check this out. Okay, perfect. The standard scaler is execute, and we call the standard scaler as well. SC, we define the standard scaler. And the next one, X. So we have these independent variable, I need to apply scaling technique to each and every attribute. So that's why I pass X equals to, we have fit and transform method. What exactly this method, guys? This is one of the standard process where where you transfer your data to clean data as well. So these are the techniques, fit and transform. I'll give you one example. Let's say you drive a vehicle, two-wheelers, four-wheelers. Every 6 months you give your vehicle to the service, isn't it, guys? The mechanical, he open everything, he fit and transform your vehicle to proper way. So that's why the mileage is good and performance is good, isn't it? So now the X equal to, I can which part, and X equal to SC, because I created SC dot fit and transform to X again. So just go ahead and do this. Okay, see, and look at this. We have X, guys, 619, 0, 42. Now the moment when you apply standard scaler, the moment when we apply standard scaler, do you see all these things is scaled or not, guys? Equal. Everything at scale now. Team, I hope understand. All the data points are equal scale among 0 to 1. I mean, some of them, few values are there, some of 4 values are there, but now machines understand, isn't it? Now machines understand. Let's close this. I will tell you what is normalizations, what is standardizations in upcoming sessions. Means I don't think so I'll complete all the deep learning in these sessions. I will try to get back to you this one, guys. Once we build sc.fit underscore transform, okay, so what do we do? Feature scaling we done. Now what is why? Customer is churn or not churn. Customer is exit from the bank or not exit from the bank. I hope understand, guys. So the next step to build the artificial neural network model, so what we do, just 1 second, guys. I got some. Okay. Now, the first thing, as you know, in machine learning, I hope you understand what is training phase and testing phase. What is training phase and testing phase? So in the training phase, definitely, guys, everybody remember we studied 10th class. In the 10th class, we trained our brain before to write a board exam. The moment when how do we train the brain? We train the brain with a lot of model papers, a lot of questions, a lot of answers from teachers, question and answers, and practical. And we train the brain well so that in the test you perform well. So that's why we split this X2, X train, X test, and Y2, Y train, Y test. So what we do, just go back to here, and I can say from sklearn dot model selections, and I can say import train test split. Perfect. So here I just call import. I import train test split package from the model selections. Just go back and we done this, guys. And now once we done, X underscore train, or I can also create X train and X test because I wanted to split X train, X test, and I don't want to declare separate Y train, comma, Y test. Once we declared, just go ahead. Okay, and let's go to the copy this one. Once we copy and train test split, you can apply. And I need to split the data to independent variable X, comma, Y, and test size. I can make it to, I hope test size minimum you can set 20% or 25% as your wish, guys. Okay, 20 size, you can try this. And random state you must need to pass because in this workshops I cannot cover all those things. What is random state, what is use of this things is very important. And let's go ahead and we can done this, guys. I mean to say that, so what we call, guys, this part, overall we have 10,000 records. From the 10,000 records we split the data into 9980 as training phase and 20 as test phase. So better than, I can say this test size as 0.2. If I take, just give me some time. This is perfect. 20 means, sorry guys, I done mistake. So 20 not, I need to pass 0.2. 0.2 means what? 20 divided by 100. So 0.2 means 2 by 10 is 0.2. So this is perfect now, right? So what we done, have a look at it. Overall, we have 10,000 attributes. From the 10,000 independent variable, I split the data into X train and X test. And Y train also, I split the data into Y train and Y test. Team understand up to this? And you can also check here, and you can also check here, X, just one moment, dataset dot shape, 10,000 rows, 13 column. And I split into X, okay? And I can say that like X underscore X dot shape, we have 10,000, and Y dot shape, okay? And now X train, we split the data into X train dot shape. Check this out. 8,000 we use for training and Y train dot shape. Just check this out. 2,000 records Y train, my bad. So just one moment. TRAIN, Y train dot shape. Team understand? And X underscore test dot shape and Y underscore test dot shape. So that means to say that we've been split the data into training phase and testing phase before we build the model. Now the next one, build the artificial neural network model, guys. As I said, we have input neurons, we have hidden neurons and output neurons. But my question is how to create this input neurons by machines. So that's why there we have, let's try to initialize ANN. As we learned, I can call ANN is equals to TF dot, if you take Kiras, okay, and dot models, okay, and then I can call sequential. Very, very important. What exactly, guys? Sequential. And then if you want to linear stack of layers, just go to my code and I can say linear stack of layers. Linear stack of layers. So what we've been so far, guys, I mean, we just import the data set. Understood? And then once we import the data set, what we done, guys? So in this part, we import the data set and we, oh no, sorry. The first step is import the required library. We import the data set and split the data sets to X and Y, X and Y. And then we apply, and then we cleaned, like we impute categorical data to numerical. And then we apply feature scaling techniques, which is called standard scaler and normalizer. Normalizer also you can do this, but at this moment I apply standard scaler. Once we done feature scaling, we X divided to X train and X test. Y divided to Y train and Y test. And what is the split ratio? The split ratio I've been done for 20 percentages, guys. So 20% means if we have 10,000 records, I can use 8,000 records for training and 2,000 records for testing. Once we done, and after that, we've been done these things, guys, and let's build artificial neural network. To build artificial neural network, what is the first thing we need to do? There's a sequential. Sequential means linear stack of layers, guys. We need to establish the layers first. Okay, many layers we have, guys. So like this linear stack of layers. As we said, right, we need to run input, hidden, and all those things. Now let's go ahead and we go back to the code. Let's sequential. Let's take help options. You can also find the detail. How do we apply the linear stack of layers? Add to model, list of layers to add to the model. When we go back, and then once we go back to this one, the first thing is, first, what is the next step? I need to add input layer. So what is the architecture, neural network architecture? Input layer, hidden layer, and output layer, isn't it? And in input layer, what we have? In input layer, we have neurons. In input layer, we have neurons. But we need to assign the neurons or not? How do we assign the neurons? So that's why Keras ANN dot add. Where what is the method? Add method. And from the add method, tf dot Keras. All right, guys. And then I can call it as dot Keras has layers, and then the dense, guys. So what we call, just one moment, the moment dense. What exactly dense? I will tell you all those things, guys. Dense means densely connected from one neuron to another neuron. So what we done, sequentials, we established a layer. What exactly dense? Connected from one neuron. So right now we didn't assign any neurons. I will tell you dot dense functions and units, or I can call it as how many neurons. Let's assume I can use 5 neurons, and then activation is equals to, one moment, I got this. No, activation equal to relu. Activation equals to relu. Relu activation, where we use, guys, input layer or output layer? Relu we will use at input layer itself. Understand, guys? So what I'm trying to do right now, just go back to the variable explorer. So I just call the ANN tf.keras model sequential. This will establish the layer. And did you see I add the input 5 units? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Already layers are there. Already layers are there, isn't it, guys? Connected activations relu. Apply relu activation functions at input layer. What is relu value? Max. You never get negative, guys. You never get negative. Units 5. Dense. What is meant by dense? These layers are connected to the neurons. This is called connections, isn't it called? This is called densely connected from one neuron to other neuron. So that's what we've been done here, relu. And then this is input layer added. Now let's add one hidden layer as well. So how to add hidden layer? The same thing in hidden layer. I just copy this one and copy. Let's apply the same things again. Ann dot add, same concepts, units 5. Also, maybe you can assign the unit 6, 7 as per your request, but you can assign to 6. And then before I go ahead to the next one, okay, sequential, let's execute this one, and I'll go ahead to the densely connected from one neurons, and then let's connect it densely connected to another neuron. Yes, guys, I can build one input layer. What is architectures I'm going to build now? I'm going to build 1, 2, 3, 4, 5. One input layer. This is called one input layer. This code one hidden layer. 1, 2, 3, 4, 5. What is the stack of layers? Sequential. We already established the layers. Means this packages will take care of all those things, guys. This packages will take care of all those things. I hope understand. Now let me add. Let's have a check this executions, guys. If you two part is done, great. Now let me add output layer now. In the output layer, what we're going to do, so in the output layer, I don't want to add any more layers, guys. So let's go ahead. Sigmoid activation functions, I told you, ann dot add. So I will apply the same things. Let's copy this and paste here. Activation out 1, and I can change to sigmoid. Sigmoid used for classifications, relu, we apply max. And sigmoid, what is the range of the sigmoid? Just now I said it is 0 to 1. So once we go ahead and have a look at this, guys, this we call sigmoid activation functions. And once we done sigmoid finally we build the architectures. What is the architecture? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and this is 1. So this is what architectures we build today, and means the ANN TensorFlow built all these architectures. Now the next one is, what is epoch? Let's train the model. To train the model, I can use one forward propagations and one back propagations. So I need to compile the ANN. I need to validate ANN.fit, and always we need to x underscore train and y underscore train, and batch size equal to 30. By default, batch size is 30, guys. When you check the fit method, I want to check this cursor here. You want to find the moment when you type the code, and I need to check epochs, guys. Epochs equal to, at this moment, first I run one epoch or maybe two epoch. What is meant by epoch? As I said, forward propagations and back propagations is, I'm sorry, this is not, I want to compile it, right? So before I need to do this, I need to compile ann dot compile. Okay, great. So what I compiled, optimizer. As I said, how many optimizer we have? We have GD, SGD, and all those things. And I can use Atom optimizer for it, guys. So just Atom optimizer, and then in Atom optimizer, as it is zeros and one, so I can say binary shift tab. Just one moment. I want to go back to the fit binary cross entropy. I hope, see, all those things you need to be understand. So that's why I said being a fresher, it's a little bit takes some time to understand. And CRO SS. If it is a binary data, that's why you can use binary. If it is multi-class, I have another practical, which is called, maybe I will continue these workshops on next week as well for CNN. And so that what is parts metrics, what is, those things will build a lot of projects as well, guys, in next week. So binary cross entropy and loss functions. We have log loss, all the concepts we have. Let's apply this loss functions we done, and metrics equal to, I can, just one moment, accuracy. Just 1 second, guys. So look at this, what we done right now, ann dot compile, we just build this neural network, input layer, hidden layer, output layer. Once we build, let's compile this optimizer Adam, because these are the optimizers. We have 7 optimizers. As I said, one is Adam, add a grid, add a delta, and we can apply the loss functions as the binary, sorry. So here you need to pass cross entropy, binary cross entropy, and metrics equals to accuracy. Perfect. Now let's go ahead and what is meant by loss functions. I told you, right? In this graph, we have output data, input data, I mean y and y hat. I need to apply the loss functions y minus y hat. So that's the reason. Just go ahead and do this here. Close this one, cross entropy. Let's have a look at this, guys. Once we do this, I try to fill an epoch. What is meant by epoch? ANN.fit. We need to train the model with batch size 30. And let's try to do the epoch part. What is meant by epoch? Forward propagations and back propagations. Let me go ahead and run it. So the moment when we do, now let's look at the systems. So here it will done the forward 2 epochs. What is the accuracy of the training, the historical data which we built, which is 76 percentages. What is accuracy? You need to build the train data. I need to increase this to maybe 20 epoch. See guys, if I reduce the loss, the increase accuracy 56 to 48, reduce the loss, accuracy increase. So here what I'm gonna do now, let's do epoch 20. Just have a look at this. If we change the epoch 20, look at this, guys. Loss, first epoch, epoch 1 by 20, 2 by 20. What is epoch, guys? I told you, right? In this examples, we done the epoch. So first epoch, second epoch, first epoch, actual predicted not equal, actual predicted not equal. The same things we've been done here. And finally, the model stops at 85.6. Did you see, guys, in 2 epoch, the accuracy is 79. But when I change to 20 epoch, we get accuracy to 85 percentages. I hope understand, guys. And the next step, we just fit the model, we train the model. And let's create a byMr equals to, and I can ann dot predict x test. We split the data, as you know, split the data into xtrain and xtest. Excuse me. Just have a look at this. byMr and byMr. So we had 0.11. So what exactly I'm gonna do? So I wanted to make some of the conditions here, and the condition is byMr equals to, did you see we have 0.1, 0.2, 0.19. So I want to make this to in the threshold 0.05. Let's have a look at this. It'll check true or false, because does 0. We take some of the threshold, because 0.5 to 0.5 to 1 it is passed, 0.5 to 1 it is failed, true or false. Anyway, so finally we can make a confusion matrix. What's confusion matrix, guys? I hope it is I mean, this is the matrix to predict the classifications part. So to confusion matrix from sklearn dot metrics import confusion matrix, right, guys? Once we done, and cm equals to, let's plot the accuracy. Confusion matrix of, always you need to build with y-test and y-pred, y-test comma y-pred, and then just cm. Have a look at this. Y-test, and let's plot the cm part. Did you see, guys? This is what I mean, these things you need to understand what is meant by classifications, regressions. As I said, this is advanced machine learning. And to check the accuracies, what I'm going to do, let's copy, and I can apply as import accuracy score and accuracy underscore score, and I can CM AC accuracy underscore score and then AC. Just go back and we check this out. So what? Y test and Y bread. Y test and Y bread. So it's take 44. Actually, it is not. Or I can say this one Y bread underscore. I'll check it to 1 and just do one more thing, guys. Let me Y test and Y bread underscore 1. I'll because you get to know few of them, and no need to worry, I'll explain in detail because when we have to check the accuracy. And finally, let's go ahead and restart the kernel. Just 1 second. I do understand some of them are new, some of them are experts, some of them are, I mean, if you know this before, that's good. But they don't ask these questions in interview, but they will ask you what are the loss functions you've been implement, what are the optimizers you've been implement. So when you attend the live sessions, when you attend the regular classes, these things would be very fantastic. These things you understand in detail. And so a lot of things we have, guys. So I tried to implement a lot of projects today, but due to some time constraint, no need to worry. I will continue these workshops maybe next week. You get to know this one, but before that, let's wait. We will done. One moment. Let's run the code entire at once. You need to restart the kernel every time. The way the mobile is hangs, you restart. The same way, once we create a many variables, we need to restart the variables to find out all the accuracies, guys. Just 1 second. Just 1 second. Okay, so the confusion matrix, cm.sklearn.matrix. Team, I hope understand, guys. So how do we build all these epochs, neurons? And I hope we can find out. And I just don't take much time. I do understand. But if you see this here, if you see this, if you just 1 moment, I'll go back to this. Let's minimize. Go back to. So what we done today, we build a TensorFlow. Okay, we build a TensorFlow till the slides, till 13 slides we completed. In these sessions, we understand what is deep learning, what is neural network, what is artificial neural network, and how to create input layers, how to create, I mean, output layers, hidden layers, what is the weights, what is neurons, what is signal processing, and what is human neural network, what is forward propagations, back propagations, epoch, and then activation functions. We have some of the activation functions we have, and we install a TensorFlow installations on your machines. And once we install the machines, I hope you can find out, like, we done some of the projects and customer churn predictions using TensorFlow, guys. And now I will stop here because we have another projects called Fashion MNIS using TensorFlow. To understand this, you has to be understand what is convolutions neural network. Might be we'll have another workshops on CNN part, and we'll build 2 projects on how your OpenCV works on images. And also we can also detect, like, how to find out. I'm going to build 2 to 3 projects, guys, over here as well. How to detect, I mean, what we called that these projects we have, and how your model detects convolutions neural network, whether it's a mode class classification using TensorFlow, Keras. We will done this, guys. So 2 projects we will continue the workshops in next week or some other time. You get to know. I hope everybody's clear, guys, up to this. I hope everybody's clear up to this. Everybody's clear. Okay. So I just the one who already enrolled, it seems most of them are enrolled students, so no need to worry. We can we can understand this, we can build this, guys, in upcoming sessions as well. All right. And that's it for today. And we can talk to you on, you can stay to the another sessions, another workshops, and we can heading toward workshop, CNN part, guys. All right. Thank you and have a good day, guys, and have a great week as well. Team, I hope you're clear. Yes, Naga, you raise your hands. Any question?
Hello.
Yeah.
Yeah, actually, you said optimizer functions, right? And then according to that accuracy was 85%, right?
Hmm.
So actually, let's consider we want the highest accuracy, like 95, 98, like more than 95, like that.
Hmm.
Then at that time, even we can check with the other optimizers, right? Like Adam,
Yes,
stochastic
you
gradient
can you
descent.
can also see, you can also change to this. When you check this, you can change to gradient descent. We can change to stochastic gradient descent as well. You can change this part. It's not Adam only finalized, but also yes, Naga.
And yeah, so is there anything that like it's a kind of like a test and trial, right? So with what kind of
Yeah, what is
optimizers
the
and with
next
what?
step? Yeah, what is the next step? No, optimizer, you have 7 optimizers. And might be there's a questions when to use which optimizers.
Yeah.
When to use which optimizers. Yes. Very good. So optimizers and loss functions. I hope you heard about gradient descent, right? In gradient descent, we reduce the loss function to reach the global minima.
Global max.
To reach
Mm.
the global minima. So here, what is meant by loss functions? Loss functions means actual minus predicted. It's not mandatory. There is no concepts that when to use which optimizer. You can use all optimizer also to test it. I hope understand.
Yes,
It's not
understood.
that only Adam you cannot apply. You can change to gradient descent as well. You can change to stochastic gradient descent as well. You can, in next class, next workshops, I will use RMS prop. If the data is image, then largely you can use RMS prop. RMS prop. I hope understand. And
Yes, understood.
the data for as we used binary class classifications. So I'll use binary cross entropy. If you see this code, I can use binary cross entropy loss functions, right? Because we have two variables. Yes or no, customer churned or not. But when you have multi-class classifications, I will change to, we do have other functionalities called sparse category entropy. Sparse category entropy we have on that case. So it's not that only, it's not limited, I can say, but yes, one thing is mandatory. In all input layer, hidden layers, we apply ReLU, and output, as it is binary, we use sigmoid, or else we'll use softmax as well. Not right now, but when the data have,
Images.
yes, images and multi-class. I hope understand, Naga.
Yeah. Yeah. Thank you. Yeah. Thank you.
Okay, so thanks everybody. And any more questions, team? Any more questions we have? I do understand I want to cover up all those things, but it's not that easy to cover up. You can't digest. So that's why we need to understand. And as much as simplicity, but still, when you enroll the session will be more fantastic. This is a big topic. So that's what I said. This is for advanced, you need to be understand machine learning, then you understand. If not, no need to worry. And I will get, you can see me on live to explanations of all the concepts step by step. And what exactly we done, CNN, and how exactly the image can understand by machines, what is meant by, look at this, if you train this image, how machine reads it. So machines reads with zeros and one formats. And when an image is trained, the image is split into pixels. The images are split into the pixels, and then it feed to the neurons. Just now I was talk about input, hidden, and output layers. And I try to build some of the projects like I just bring out two projects for next week or sometimes. The first one is Fashion Amnes using TensorFlow. So these images are inbuilt images for Kira's library, and uh, and also how to do mood classifications. You sometimes you guys are happy, sometimes you guys are sad, and using OpenCV and CNN how to use the mood classifications we also understand in next week. So no problem. If you, I want you to enroll the classes which new batch is going on. If you already have, and you can refer to your friends if you want. And stay tuned for any further questions. You can reach out to the admin guys. All right. And thank you for joining today's workshops. And appreciate your time and effort. And appreciates to stay for 2.5 hours. Thank you so much, guys. And you can connect with me on the classes regularly from Monday to Friday, and stay the Naresh IT portal for any upcoming workshops. Have a good day, have a good week, and God bless you. Bye, guys.